got the review pulled up. All right, we have 12 questions on the review. I mean, on the test, not on the review. There's a lot more than 12. We have 12 questions on the test. Anything that we have talked about is fair game, but I'm going to give you guys some direction on what you need to really focus on, okay? If you look up at the screen, I have 5 through 22, and then the simplifying, and on the next page it's the expanding, the multiplying. You'll have one of the simplifying ones with all the crazy exponents. You will have one that is a binomial raised to a power that you have to FOIL out. But a majority of your test is factoring. Okay, everything will be factorable. This is the only test that probably everything will be factorable. Other than that, you might have some that don't work out and are prime and that sort of thing, but not on this one. We're just really working on our factoring skills for this test. Then we're going to get into chapter 1. Yeah.
Should we cross out the other one?
Yeah, you can.
12 questions?
12 questions on the test, yeah. This review, guys, I am not grading. I know it's still on your to-do list. As soon as I'm done talking, I'm going to change it to not graded. I just kept it on so you guys would see it. You don't have to do this as we go along. Don't try and write everything down as fast as you possibly can. If you've already done it, you want to check, fine. If you want to just follow along, watch what I'm doing, listen to what I'm saying, make some notes, and then tonight maybe re-watch the video, write down the problems just for extra practice. It's totally up to you. But I am not grading this. But what you guys should have in your mind every single time you're told to factor, it is not going to say factor by finding the GCF. Factor by, it's going to say factor. So in your mind, you need to go through like a checklist of what should I do first? What should I look for? The first thing we always look for is a GCF. What is GCF? Greatest common factor. Can you pass it over, please? Greatest common factor. And then we look and we see how many terms we have left over. If there's only 2 terms, check to see if it's the difference of perfect squares. If there's 3 terms, check to see if it's a perfect square trinomial. Some of us still aren't really great with that, so then we have to just factor. Multiply A times C. Factors of the last number that multiply to give you the middle, or the combination of the A and C. If there's 4 terms, we need to group. But it's just going to be a hodgepodge of problems, and you are going to have to factor, and you have to factor completely. Don't leave anything unfactored, and I'll show you what I mean by that in a second. Thank you. So if we look here, let's look at number 5. I'm going to go down the left-hand side, then back up the right-hand side. But if we look at number 5, the first thing we ask ourselves, what? Greatest common factor, okay? Is there a GCF in number 5? No. So I'm going to multiply A times C since this is a trinomial. Yes, I know that A is 1 here, but let's just get in the habit of doing the same thing. So 1 times negative 15. I need factors of negative 15 that multiply to give me negative 15, but add to give me 2. We have positive 5, negative 3. You guys agree? Okay, so check it. What's positive 5 times negative 3? Negative 15. 5 minus 3 is 2. So yeah, good to go. All right, I'm going to go down the left-hand side, like I said, and back up the right. So number 7, no GCF. So A times C. Factors of 6. Positive 6. That multiply to give you 6, but add to give you a negative 5. Negative 3, negative 2. Last period, someone was like, but negative 6 and positive 1 works. Well, it kind of works. Because negative 6 plus 1 is negative 5. I agree. But negative 6 times 1 gives me a negative 6, not a positive. So make sure you just pay attention to signs. All right, look at number 9. First question we ask? GCF. Is there one?
3.
Yeah, 3 goes into all these. So take it out. Go ahead and take it out. First thing you need to do. So I take out my 3, and I'm left with 5m squared plus 7m plus 2. All right, this is no longer, we don't have to look at it anymore. So now I say, okay, well, my A term is not 1. So let's A times C. 5 times 2 is 10, right? What are the factors of 10 that multiply to give you 10, but add to give you 7? Agreed. So m plus 5 and m plus 2. Am I done? No, why not? Good, why not?
The 5
My A term is not 1, right? I have to look and say, uh-oh, A is not 1, so I have to divide both of my factors by that A term. 5 divided by 5, nice and pretty. It's just 1, correct? So this becomes 3 times m plus 1. And then 2 does not divide pretty by 5. So that becomes my coefficient of 5m plus 2. Now we're done. Right? If you guys do half of the factoring, then you'll get half of the points. It's very important that you factor it completely. Look at number 11, GCF? No. So A times C, 2 times 12. What are the factors of 24 that are going to multiply to give me 24? God bless you, but add to give me 11. Good, 3 and 8. Plus 3 plus 8, because I have a bunch of pluses in there. What is my A term? 2. So that means I need to divide everything, all the factors, by that A term. So 3 divided by 2 doesn't come out to a nice pretty whole number, so that becomes 2n plus 3. 8 divided by 2 is? So I have n plus 4. Question so far. Every single problem, they're not going to go in order. It's not going to start off like this and then get progressively harder. I randomized the questions, so there might be the first one's grouping, and then the second one's GCF, and then the third one's difference of perfect squares, whatever. Just ask yourself the same question every time. Can you see?
Yeah.
All right, 13. GCF. Is this a perfect square trinomial? You guys are like, wait, what?
No.
Is the first term and the last term perfect squares? No. So that means I just have to do my normal, A times C. 4 times negative 15 is negative 60. What are the factors of negative 60 that multiply to give me negative 60 but add to give me a positive 4? Okay, so plus 10 and minus 6. Okay, agreed. Is my A term 1? So what do I need to do with it? Okay, I'm going to divide both by 4. Well, wait a second. This doesn't divide, neither of them divide out pretty. Can't put it out in front yet. Good. Can we simplify 10 over 4? Yeah. Both by 2 becomes 5 over 2. Can we simplify 6 over 4? Yeah, becomes 3 over what? 3 over 2. Now, those don't simplify anymore. They don't reduce, they don't divide evenly, but we can make both of these our coefficients. So this becomes 2p plus 5, and this becomes 2p minus 3. Good. Good. All right, 15. GCF? No. So A times C. What's 4 times 1 is 4. Factors of 4 that multiply to, I'm going to use an X. Multiply to give me 4 and add to give me negative 5. Negative 4, negative 1. Good. My A term is not 1, so I'm going to divide each factor by 4. 4 divided by 4 is just going to give me 1, so I have x minus 1. And then this becomes 4x minus 1. Questions? No? All right. What's up?
Why did you use that, the trinomial, the three terms trinomial thing?
The perfect square? Okay, good question. Very good question. Camilo said, how come we didn't use the perfect square trinomial? Which I do. I'm glad that you said that. Is 4b squared a perfect square? Yeah, 2b, right? Is 1 a perfect square? Yeah, 1 and 1. So just think. Say we went 2b plus 1 and 2b minus 1. I'm glad that you brought that up. All right, that does kind of fit the pattern, but this middle term messes that up, because if you were to multiply this out, you get 4b squared plus 4b minus 1. So that's good thinking. I'm really glad you thought of that. And if you were to factor it out that way, I would have done that and then told you to, just make sure you check. That's good, though. All right, look at 17. GCF. No. A times C? No. Well, wait, what is this then? Is this special? Why is this one special? It's the difference of what? Perfect squares, or two squares. What can you break 9n squared into? 3n, 3n. What can you break 5 into? 5 and 5. So this just becomes 3n minus 5, 3n plus 5. The plus and minus doesn't matter where it goes. You just have to have one of each. The reason why this is the difference of perfect squares, guys, when you multiply those two binomials back together, your middle term would cancel out, and it would result in just n squared and then minus the number. What's 19 without even looking at it? Yep, x plus 3x minus 3. Now, somebody at last period asked a great question. They said, how come this doesn't work when it's a plus? So watch. When I multiply these two back together, I get x squared plus 3x minus 3x minus 9. So what happens to the middle terms? They cancel, right? So we have x squared minus 9. If this were x squared plus 9, and you said, well, doesn't that just become x plus 3 and x plus 3? No, because when you multiply that out, you get x squared plus 3x plus 9. So you'd get x squared plus 6x plus 9. It doesn't work out that way. And another reason mathematically it doesn't work out that way, I know some of you are like, I don't really care, but I'm going to tell you anyways. Another reason it doesn't work out that way is because eventually we're going to solve. We're going to move past this just factoring, and we're going to actually solve, meaning set them equal to 0. So if you set x squared plus 9 equals 0, and then over here, turn that down, please, x squared minus 9 equals 0. Right? We're going to add 9 to both sides over here. Add 9, add 9. I get x squared equals 9. Take the square root. You get x equals plus or minus 3, which is what this is, plus or minus 3. Here, if you subtract 9, you get x squared equals negative 9. What happens when you take the square root of a negative number? It's imaginary. It becomes I. So it turns from a real solution to an imaginary one. So that's why it just doesn't work out that, oh, there's a plus, I'm just going to stick a plus in it. It mathematically doesn't work out that way. All right, let's look at 21. GCF. Look at the smallest number. Is anything going to go into the smallest number that'll go into everything else? That'll kind of give you a clue. No. So if we have 4 terms, guys, what do? We group. Watch how I group this. The first 2 and the second 2. That third term, that sign has to stay with it. If it's negative, it's going to make a big difference. But what can I take out of 42a cubed and negative 24a squared? 6a squared. So when I take out my 6a squared, I'm left with 7a minus 4. Well, look at that second parenthesis. It kind of already looks like that, doesn't it? Right. Do you see that negative that's stuck in front of that? You want to take that out. So if I take out a negative 1, if I divide this by negative 1 and this by negative 1, I end up with 7a minus 4. Do you now see the same parenthesis 2 times? All right, that's our new GCF. We discovered the GCF. So I'm going to take that out, right? 7a minus 4 in its own parenthesis 1 time, guys. Look, when we took out, yeah, you're right. When we took out our 6a squared, did we write it more than once? No. So anytime you take out a GCF, you write it 1 time. But anything that's left over gets its own parenthesis. Before you guys pat yourself on the back and move to the next one, check to see if that factors anymore. Is that the difference of perfect squares? No. But if it was like this, would it factor more? Yeah, what would this have become? 2a plus 1, 2a minus 1. So whenever you guys think you're done, just kind of check again. If you have a minus sign and there's something square, just take a quick check.
Would you just have 3 parentheses, like 7a minus 4 and then
Yep.
2a or whatever?
Yep. All right, let's go on over to 22. GCF? Lots of big numbers? No? Okay. I have 4 terms, though, so I need to group, correct? All right, what am I going to take out of 32? Yep. Yep, I'm going to take out a 4, right? 4x. Okay, so 4x squared. 32 divided by 4 is 8. X cubed divided by x squared is x. Then I have minus 12 divided by 4 is 3. My x squareds cancel out. So that kind of should guide you guys onto what your next parenthesis should look like. What should your second parenthesis look like if you factored this correctly? 8x minus 3. So what would you divide negative 56 by to make it a positive 8? What kind of 7? Negative. That negative right there needs to come out. So I'm going to say negative 7, and I'm left with 8x, negative 7. And what's 21 divided by negative 7? Minus 3. So now you have discovered the common factor. They both have an 8x minus 3 in them, so take it out, write it one time, and then what happens? What's left over? 4x squared minus 7. Can you factor that anymore? Is that the difference of perfect squares? No. All right. What's 20? Tell me what the parentheses are for 20. 4n minus 1? 4n plus 1. Difference of perfect squares. Great. Nope. Good question. You can put 4n plus 1, 4n minus 1, just as long as you have one of each sign. What would 18 be? 5x plus 4, 5x minus 4. Now, you guys might come to a problem. Say it was, that looks like the difference of perfect squares, doesn't it?
Yeah.
But neither of those are perfect squares. Do you notice anything?
There.
You could take out a 2, right? There's a GCF. If I took out a 2, I'd be left with x squared minus 100. And then what does that become? X plus 10, x minus 10. So that's why it's so important. If you look for a GCF first. Something might look like it should be a perfect square, but I don't really see it right away. Take out the common factor. What about if this was like this? Look, negative 2x squared plus 200. Take out a negative 2. Right, good. Okay, good. Just so you guys see it. All right, now this first one, if you just jumped into factoring and said a times c, 12 times 18, hopefully you would go, wait a second, is she really going to give us one like this big? I have to write all these factors out? Probably not. So in that moment, check to see, wait, did I forget the GCF? Is this a perfect square trinomial that I could just figure out real quick? Is there a GCF between 12, 33, and 18? 3, good. So if we take out this 3, life becomes a lot easier. I'm left with 4m squared plus 11m plus 6. So this is not, we don't have to look at that anymore. 4 times 6 is 24. What are the factors of 24 that are going to multiply to give me 24, but add to give me 11? Good, plus 8 plus 3. And then what is your a term that you need to divide both of those factors by? 4, good. So don't forget that 3, that initial GCF that you took out 20 minutes ago. That 3 is still there. What is 8 divided by 4?
2.
So m plus 2. And then 3 divided by 4, not great. So this becomes what, babe? Perfect. 4m plus 3. Good. Good, 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 good. Scooting along. 3 times m plus 2 times 4m plus 3. Don't pick on the new guy.
Yeah. Okay.
I gotcha. I gotcha.
Thank you. Appreciate it.
I'm going to post this video. Yeah. All right, 14. 14 looks a lot like 13 if you guys look at it. Is there a GCF? No. So I'm going to say a times c, and I get negative 60. What are the factors of negative 60 that are going to multiply to give me negative 60, but add to give me a negative 4 this time? What kind of 10? What kind of 6? Negative 10. Positive 6. Good. And since my a term is not 1, I'm going to divide both by 4. Again, guys, neither of these divide out pretty, but they will simplify. In order for you guys to get full credit, you have to fully simplify. So this will become a 5, and this a 2. This will become a 3, and this a 2. So your answer would be what?
2n minus 5.
Perfect. 2n plus 3. Good job. As we go back up the page, they get a little easier. What's going on here? GCF? No. So A times C. 2 times negative 5 is negative 10. Factors of negative 10 that are going to multiply to give me a negative 10, but add to give me 3. Positive 5, negative 2. What do I do with my A term? Divide. Good. I'm hoping that you guys are like, oh my gosh, you just keep saying the same thing. Good. That's what factoring is. You just keep doing the same thing. A couple days ago when we started this, you guys didn't sound so great. You guys are sounding a lot better now, so the repetition is good. I mean, you may not think it is, but it's great. GCF. No? Okay. So A times C. 3 times 8 is positive 24. We haven't had this combo. Positive 24 when I multiply by a negative 14. Good. Negative 12, negative 2. And my A term again is not 1, it's 3. So we're going to divide by our A term. So my answer becomes n minus 4 and? Good job, guys. 3n minus 2. Very good. GCF? Yeah, if you guys didn't see it, you just make your problem a little longer. You'd get it out at some point. But take the GCF out as soon as you can, and then the problem becomes a lot easier. 18 divided by 2 is 9, and then 40 divided by 2 is 20. So now I have factors of 20 that are going to multiply to give me 20 positive, but add to give me a negative 9. What would that be? Factors of 20. 1 and 20, 2 and 10, 4 and 5. 5 and 4. What kind of signs on both of them?
Negative.
Good. Negative 5 and a negative 4 when I multiply gives me a positive 20. But a negative 5 and a negative 4 when I add gives me my negative 9. And then this one's a no-brainer. There's no GCF. So what are the factors of 8 that multiply to give me a positive 8 and add to give me a negative 6? Good. Negative 2, negative 4. Good job. So any kind of factoring that we've done, you guys will see tomorrow. You might see a combination. You might have to take a GCF out, then factor trinomial. Might have to take a GCF out and group it, and then you have difference of perfect squares left. Like, there's lots of stuff that you guys could see, so just please be aware. Bobby, did you need something, honey? Okay. All right, look at 27. We're going to do these last 4. Some of you did real well on this, and some of you not so well. So let's talk about it. Yes, that's why we're going over it. All right, when you have a parenthesis with an exponent, raised to an exponent, this goes to everything. Everything, everything. You guys can do whatever you want, the order that you want to. I'm just trying to show you what I think is easiest to keep you from getting confused, because some of you got real confused. This becomes 3 to the negative third, x to the what? Negative 12th, y to the 9th, and z to the negative third. At this point, what I would do is I would come over here and I would say, okay, anything that has a negative exponent is going down. Anything that has a positive exponent stays up. If this number were negative, just because you move it to the bottom of the fraction does not make it positive. So don't make that mistake. But that's the easiest way to look at this. I would move 3 to the third down here. X to the 12th down. Z to the third. Yes? And then what happens with y to the 9th? It stays on top. Then the only thing now that you have to do to simplify is 3 to the third power, which is 27. So your final answer is y to the 9th over 27, x to the 12th, z to the 3rd. Some of you guys got yourselves so confused, and it's because you're trying to do too much at one time. Just take your time and simplify little by little, like this one. This problem appears like there's a lot going on, but there really isn't. There really and truly isn't. Okay, what number is right here? 1. Okay, if you don't see 1, go ahead and write it. You can distribute this exponent to that 1. This -2 is going to go here, 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 and there. There, 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 and there. It's going to a lot. Some of you try to do all of your work within that 1 parenthesis. And it showed because your answer made absolutely no sense. So let's just go through and distribute the exponents to everything. So if you're going to keep that -1 there, fine. -1 to the -2, right? Then x to the what? -8, y, -6, z, -9. I would not try and start moving things all over the place right now. 18, you're right, my bad, thanks. Thank you. Just go ahead and distribute that exponent, then worry about moving stuff. So now I have my number -7, and it's to the -2nd power, z to the -6, y to the 10th, and x to the -22. Where am I getting these numbers from? -22, where'd I get 10? I'm multiplying. Exponent raised to a power, we multiply. Now is when I would start to move stuff around. I don't like all those negatives, so I'm going to say, okay, let me move stuff around so I have only positive exponents. How do you make a negative exponent positive? You move it, right? If it's negative in the numerator, move it to the denominator and vice versa. So I'm going to say, okay, -1 squared, x to the 8th, right? Y to the 6th, z to the 18th. Everybody agree? All right, so then on the bottom, I'm going to move -7 to the top. That becomes squared. Z to the 6th. Does y to the 10th move? No, keep it on the bottom. And then x to the 22nd. You guys with me? Now, from this point, guys, all of your exponents are positive. Wherever the bigger number is, when you subtract, that's where the variable is going to stay. What I mean by that, look at z's. There's 6 z's on top and 18 left over on the bottom, yeah? You guys see 6 on top, 18 on the bottom? So the leftovers are going to be where? Why are they going to be on the bottom? Because there's more of them there already. So just pay attention to that. So as you simplify this, 7 squared, -7 squared is 49. -1 squared is 1, okay? So x's go in alphabetical order. I have 22 on top and 8 on the bottom. So I subtract because we're dividing. What's 22 minus 8? 22 minus 8? 16, 14, what is it?
14.
It's 14, so I have x to the 14th, and it's going to go on top. Why is it going to go on top? Because there's more of them up there. That's where the bigger exponent is. Okay, that's done. The next letter in the alphabet is Y. Where are my Y's? Both of them are on the bottom, right? So how many Y's do I have? Perfect. Good job. Now the last letter I have is Z. I'm going to subtract, but where are my Z's going to stay? So when I say 6 minus 18, 18 minus 6, whatever, if you guys are like, well, it's negative. If it's negative, then put it on the bottom. What I'm trying to show you is there's 6 Z's on top and 18 on the bottom. You're going to have 12 left over. Since there's already 18 on the bottom, that's where the bigger number is. That's where they're going to stay. Does that make sense? You guys don't have to do it that way. If you want to do the minus the negative, that's fine, but just don't get yourself confused. And then the next two are done. Lots of you mess this up. I got this. Is that what that means? No. When you have a binomial raised to a power, whatever that power is how many of them you have. Okay, so I had a lot of you got to this point. And then I had some people that just drew like 19 arrows all over the place and started multiplying everything at one time. Can you do that? No, either leave the binomial in the front or the binomial at the back. Just leave it alone, bring it down, deal with it separately, but go ahead and FOIL two of them together. So when you have negative x times negative x gives you x squared. Negative x and a negative 7 is plus 7x. Negative 7 and a negative x is plus 7x. Negative 7 and negative 7 is plus 49. Everybody with me? So combine like terms, x squared plus 14x plus 49. And now we just multiply again. The first term multiplies to everything in the second parenthesis. Then you multiply the second term to everything in the second parenthesis. And then combine like terms. So do this with me. Negative x times x squared is? Good, negative x cubed. Negative x and 14x is? Negative 14x squared. Negative x and 49 is minus 49x. All right, now the numbers might get a little bigger. You might have to do a little side work, but what's negative 7 times x squared is minus 7x squared. Negative 7 and 14, well, what's 14 times 7? 8, carry the 2, negative 98. And then negative 7 and 49. 49 times 7, 63, carry 6, 343. So negative 343. And now combine like terms. Does anything other than your first term have an x cubed? So negative x cubed. Now I have negative 14x squared and a negative 7x squared. Yep, negative 21x squared, thank you. Negative 49 and a negative 98. 49 plus 98. 147, okay. Minus 147x minus 343. Guys, I didn't do that little work over here on the side, here, here, and here. I didn't do that for show. I do that all the time. I don't do all this stuff in my head. I write it down. You guys are not going to have a calculator, so write it down. All right, let's do the last one, then we're done. How many 2x minus 3s do I have? I have 3 of them, so I'm going to write all 3 of them down. 2x minus 3, 2x minus 3, and 2x minus 3. I'm going to keep this first parenthesis, bring it down, and FOIL the other two. 2x times 2x, 4x squared. 2x and a negative 3, minus 6x. Negative 3 and 2x, minus 6x. Negative 3, plus 9. So you have 4x squared minus 12x plus 9. And now we just multiply again. 2x times 4x squared is 8x cubed. 2x and a negative 12x is negative 24x. 2x and 9 is 18x. Negative 3 and 4x is negative 12x squared. Negative 3 and negative 12 is plus 36x. And negative 3 and 9 is minus 27.
The 18x or the 24x is this?
Yeah, I forgot the 2. Thank you. Whoa. Now we do what? Combine like terms. So 8x to the third. Negative 24 and a negative 12 is?
Negative 36.
Yep, negative 36x squared. 18 and 36 plus 54x, and then minus 27. And that, ladies and gents, is the end of our review. Bobby, thank you. If you guys have questions tonight, you can shoot me an email. I may not respond until later, but if you have a quick question, feel free. But I will post